Today we're going to be looking at this past TMUA problem. This problem's a very good exercise in understanding how the roots of a quadratic relate to the coefficients. So let's have a look. We're given this quadratic expression x squared minus 14x plus 9, and we're given its factorization, x minus alpha times x minus beta. So alpha and beta are the roots. And now we're asked to find explicitly x minus the square root of alpha times x minus the square root of beta. So you can see we have some quadratics here, and we're asked to figure out which one of them corresponds to this factorization. So the first thing that a lot of students try is to actually find alpha and beta themselves. We can use the quadratic formula to find the roots. So we're going to get x equals minus 14 plus or minus the square root of 14 squared minus 4 times 9. That's all going to be divided by 2. We're ending up with minus 7 plus or minus 2 root 10 after some calculation. But this isn't going to be very helpful to work with, because when we try to expand out this, we're going to have to take the square root of minus 7 plus or minus 2 root 10. And that's going to be pretty difficult to do. And as it turns out, it's unnecessary. So let's think about another way that we could try to get some information about alpha and beta. We know that x squared minus 14x plus 9 is equal to x minus alpha times x minus beta. If we expand this out, that is x squared minus alpha plus beta times x plus alpha beta. And immediately, if we compare coefficients, we're going to get, from comparing these two constant terms, 9 equals alpha times beta. And by comparing these x terms, we're going to get that 14 equals alpha plus beta. So at this point, you might be tempted to solve these equations simultaneously. But what you'll find if you eliminate one of these variables is that, well, these equations are describing the roots of this quadratic. So in fact, when you try to eliminate a variable, you're just going to end up with the same quadratic. It's just going to be in terms of alpha or beta instead. So we'll be back where we started. But there is some other stuff we can try. So what about the same type of approach for x minus root alpha times x minus root beta? Let's expand this out. We have x minus root alpha times x minus root beta is equal to x squared minus root alpha plus root beta times x plus root alpha beta. So actually, if we can find root alpha beta and root alpha plus root beta, then we'll be done. We're going to have the quadratic. So root alpha beta, actually not that difficult. We know alpha times beta, so we can simply square root that. We're going to get 3 is equal to root alpha beta. And now we need to find root alpha plus root beta. Again, working with alpha and beta themselves, the roots themselves, is quite difficult. So maybe we want to think, do we have a relationship between the quantities that we know and the quantity that we want? So we want root alpha plus root beta. Do we have a relationship between that and alpha beta and alpha plus beta? And in fact, we do. Let's say we write out root alpha plus beta and square it. We're going to end up with alpha plus beta plus 2 times root alpha beta. So we know root alpha beta is 3, and we know alpha plus beta is 14. So this is going to be 14 plus 2 times 3. In total, that ends up being 20. And now if we simply square root both sides, we will get root alpha plus root beta is equal to root 20. So if we look at this quadratic over here that we want, we know this term over here is equal to 3. And this coefficient is going to be minus 20. Root alpha plus root beta will just be 20. Which means that the answer we are looking for is option C. x squared minus root 20x plus 3. Okay, I hope you all enjoyed this problem. Thank you so much for watching. I'll catch you all in the next one.